Turning on the GC by opening all three gases by turning helium first, air, then hydrogen. Second, turn on the GC by the switch button on the side. Notice that the GC is giving us set file loaded. After this is done, we're going to continue to turning on the oven first, the injector, and then the detector temperatures from the control panel. Just remember that the flow rate should be measured before turning on any of the temperatures. So the manual suggests to turn on by pressing the oven temperature. The message on the monitor is saying that oven temperature actual is at 24, but it's actually off. But okay, to turn on the oven temperature, we press the on, and now the set point at 20, the actual at 24. So when I turned off the GC last time, I set it at 20 degrees Celsius, where it's actually now at 24. So now if I'm gonna fire up the GC, the oven temperature should be 20 to 30 Celsius lower than the lowest boiling point of any mixture. So now typically I put it around 45, so I press 45 on the control panel and I hit enter, and while I'm hitting enter, the monitor changes to a set point of 45, so I set it to 45 and the actual 32, and as you see, the GC is heating up to match the set. Now that the oven temperature is set, we're going to set the injector temperature. Remember, the temperature is being set after the flow rate is measured, just because we don't want to melt the flow rate tubing. Now that after the oven temperature is being set, next the injector temperature. We're dealing with detector A, so we're gonna press at injector A right there. As you could see, the set point from last time was 0. Typically the injector temperature be around 20 to 40 Celsius higher than the oven. So I'm gonna put it at 125. So 125, it's writing 125. Then we hit enter. As you press enter, the monitor is saying that the set point temperature is 125, where it's actually at 25. So the GC is going to heat up the injector port until it matches the set point. After the injection temperature is being set, we go next to set the detector temperature. We're dealing with detector A, so we're pressing detector A, and the monitor telling us that the set point at detector A is 0 from last time. So we choose a temperature for detector A. Typically it would be 20 to 40 degrees Celsius higher than the injector temperature. If you remember, we set the injector to 125, so I'm gonna go around 2050 as I'm pressing the number on the control panel. It's showed on the monitor. If this is flashing, you know it's not set yet. For you to confirm the number, you need to go to enter, press enter, and now it's confirmed. So you confirm the set point at 250. The actual is around 25. The GC is going to take a while to heat all the detector to the right set point. A quick recap, we set the oven temperature first, then the injector temperature, then the detector temperature, and we wait for all temperature to reach the set point. To confirm whether the temperature of any of the oven, injector, or detector reach the set point, just press on the button itself, and it changes on the monitor. I'm pressing detector right now, and the oven, as you can see, so the oven reached the set point, so we're okay with that. Injector, it's reached the set point. Detector A, we're waiting for the detector to reach the set point. As soon as all temperature reach the set point, this should be ready. While waiting for system readiness, crack the air and the hydrogen valves to the left wide open. This is, of course, after measuring the flow rate. After that, we would wait at least 15 minutes. Then we will fire up the GC. As you could see, after the detector temperature reached the set point, the GC is now ready. It's been 15 minutes. Just a quick recap, we opened the air and the hydrogen valve wide open. Just to get to the quickest way possible to ignite the flame, I usually close the air valve. So now hydrogen is open. Hydrogen is wide open and the air is shut. Make sure to record the split vent and the purge vent flow rate. That is also going to be in a separate video before trying to ignite the flame. If I'm lucky enough, I would ignite the flame just by pressing on the FID igniter button. As I'm pressing, I'm going to show you how's it going to look like. I pressed a couple times. I didn't hear a pop. I'm checking for a flame by the condensation, and it didn't light up, so I'm gonna try to light it up with a barbecue lighter. That's the hydrogen getting ignited. As after hearing the hydrogen pop, we'll check for the condensation. There is some condensation. The other way to check by pressing signal 1, which is on detector B, is the detector we are working on. It's 0.3. That means the flame got distinguished. So we need to feed that by reigniting the flame. You could hear the pop. While hearing the pop, the signal is increasing. Keep in mind, this is just hydrogen. The air valve is shut. Now, I'm gonna open the air a little bit at a time until I reach a good mixture. So I still have flame, and I'm gonna check by condensation. You can see the condensation on my safety glasses. But again, signal the flame got ignited. Turn off the air again. Try to ignite the hydrogen. Could you see it's jumping all over? The secret of igniting the flame every single time is by waiting for the gas to go through the whole system, at least for 15 minutes. I'm opening the air right now. As you could see, it's decreasing. So typically we would look at a signal around 9.9 or 4.5, a steady signal. This is not steady. As you could see, it's jumping all around. So as I'm opening the air hydrant, there's another pop. As I'm opening the air valve, now the air valve is wide open. I have a steady signal and it's around 3.9 to 4.1. And I could see the condensation on my safety glasses. Decrease to 3.8, it's fine. The system is ready. Just a quick recap of how to check for the signal. Go to the signal button. As I'm pressing the signal button, it tells me that signal 1 is assigned to B. Okay. Then, when I press signal button second time, it tells me what signal B set point is, which is 3.7, which is typical. I would wait a couple minutes just in case the flame get distinguished somehow before running my sample. As you can see, we have two detectors on this GC. Detector A, the far back, which is the capillary FID column, and detector B is the packed FID column. We ignited detector A, as you could see from the condensation of on my safety glasses. Detector B is not lit up because we didn't ignite detector B. We were working with detector A all along. If you go back on the video, when setting up the temperatures, if you go back to the video, when setting up the temperatures, we chose oven temperature, which is 1 for both detectors. But when we set the injector temperature, it was injector A. And if I press an injector A, it's telling me that injector A temperature is 125 and the set point is 125. And when we ignited detector A temperature is 250, set point, and it's actually at 250. And again, detector A is the one lit up. So that is consistent because when pressing on injector B, it's off. We didn't ignite injector B or detector B, and detector B is also off. But for some reason, when we talk about the signal itself, so when pressing on signal 1, so signal 1, but when pressing at signal 1, so signal 1 is 3.7, so it's the ignited signal, so it's telling us there is a flame. Signal 2 is 0.3, there is no flame. So just by looking at the detectors, detector A should be signal 1 because there is a flame. Detector B should be signal 2 because there is no flame. But there is a small glitch at the machine when we talk about signals, it's the other way around. So signal 1, when there is a flame, if I press a signal 1 button again, it's telling me that signal 1 is at detector B, where it should be at detector A. I don't know how to fix that glitch, but it's been working that way. If you are working with the temperatures, you put A. If we're working with the flame itself, we recognize it as B.